Daphnia Tech cuts carbon in wastewater treatment. Utilities balancing the dual pressures of decarbonization and tightening water quality standards may soon have a new tool, a nature-based treatment system powered by Daphnia, a type of microscopic freshwater organism. New research from the University of Birmingham shows that Daphnia-led tertiary treatment could cut life cycle carbon emissions from wastewater treatment by up to 99.8% compared to traditional technologies. Findings published in Water Research estimate emissions of just 0.006 kilograms of CO2 per cubic meter of wastewater, down from the 0.316 kilograms typically associated with conventional systems. Over an annual flow of 100,000 cubic meters, that equates to over 30 tons of CO2 avoided. Unlike many existing systems, which are assessed primarily on immediate pollutant removal, this study applied a full life cycle assessment, LCA, factoring in construction, operation, waste management, and system end of life. It also integrated chemical data, accounting for persistent and mobile toxic substances, PMTs, and micropollutants, which are increasingly under regulatory scrutiny. This more comprehensive approach highlights how Daphnia systems not only use less energy and fewer resources, but also reduce long-term chemical exposure risks to ecosystems and human health, key metrics for regulators and asset owners seeking future-proof solutions. Scalability, waste reduction, and commercial interest functioning as biological filters. Daphnia consume algae, suspended solids, nutrients, and even hard-to-treat micropollutants like pharmaceuticals and industrial chemicals. The process eliminates the need for added chemicals and produces minimal secondary waste. An operational example handling 21 million liters annually yields just 1 to 2 tons of residual solids, material that's subsequently processed into biochar, reducing volume by around 80% while creating a carbon-rich reuse product. This waste-to-resource pathway supports circular economy models and improves the treatment system's end-of-life profile. Beyond emissions cuts, Daphnia systems offer tangible environmental benefits. By removing excess nutrients and pollutants, they help mitigate eutrophication and improve downstream water quality, important for operators managing assets near sensitive ecosystems. The Birmingham-led study, underpinned by Horizon Europe Upstream funding, was developed with support from engineering firm Stopford and tech provider Daphne Water Solutions, signaling growing commercial interest. As utilities move toward full-scope carbon accounting and face stricter chemical compliance obligations, nature-based solutions could shift investment criteria for tertiary treatment infrastructure. While not positioned to replace all conventional processes, Daphnia-based technologies present a viable option for utilities aiming to meet both carbon and water quality targets in a cost-effective, regulatory-aligned way.